everybody. Adam with FANUC. We're going to have a fun one today. It's going to be a 2-for-1. We're going to talk about iRVision and how to get it set up in RoboGuide so that you can do preliminary vision setup and testing offline. It's a 2-for-1 because you get to learn how to do it offline, and basically we're going to go through a simple iRVision setup to show you how those tools work. So you're going to get both pieces of the puzzle. Got a lot to cover, so I'm going to do my best to scoot along pretty quickly. So here we go. Let's dive in. So in your RoboGuide work cell, I should note that the first thing you want to make sure is that when you built this work cell and set up your robot, that you actually added iRVision. For this case, I chose the basic iRVision 2D package. That's what you would buy on your real robot. So that has to be on here. Okay. And let me minimize this. So the next thing you have to do is right here in your work cell tree, you'll notice a vision subset. I'm going to right click on this. By default, this will be disabled. There will be no checkbox there. So you have to come in here, tell it to enable vision simulation. You'll get a nice little pop-up box on the screen that says, hey, I need to restart your robot. Click yes, let it reboot, and then you'll see this. Without that, none of the rest of this video is even going to work for you. So I've already done that. I have the happy little checkbox. That's great. So now the next thing I need to do is put a camera in the work cell. As you can see, I've already thrown in this connecting rod here. I've set up an LR mate on a table with a nice little vacuum gripper. I've done all this preliminary work to keep the video short. If you need to understand how to do that, watch my RoboGuide tutorial. But right now we need to put in a sensor. Right click, add the vision sensor. What do I want to add? I want to add a 2D camera. I'm going to go ahead and snag one of the images built in from the FANUC library. In this case, most common, you'll probably be putting this camera on your robot, the Koa brand SC130. So I'm going to hook that in here. Okay. You'll see that it added a sensor unit portion and a camera portion. If I double click camera, I can actually rename this. So I'll name it the Conrod camera because it's going to find connecting rods. Say OK. Where did it go? There it is, way up in space. So now we have to physically, if I zoom in, you'll see our little camera here. We have to physically position this very similar to how you would in a real life work cell. So I'm going to put this thing right now just kind of generically, over where I know my part is going to be, where the work is going to get done, something like that. Side view does not need to be that high up in the air. We'll bring it down. I don't want to bring it too low to where this robot can be banging into it during normal operation, just like you would in real life. We'll start here and we'll start dialing it in a little bit more. So now that I've added the camera physically as a sensor and I've enabled the vision, the next part is the vision properties. Get into this screen here, and we're going to virtually, in the virtual world, we're going to plug in that camera to the robot. So I'm going to click on port 1, and I'm going to look for my devices. Here's our sensor unit, the connecting rod camera. So I'm going to click that, and you got to hit apply. Hit apply. There we go. So now I have, in the virtual world, plugged in my camera to the robot, just like in the real world you would plug that into your controller door. So there's the preliminary setup. Let's start testing this and see how we like the setup before we move into the actual vision. At the top of your screen, you'll see the Robot tab and Internet Explorer. Let's click that. You'll get a nice little pop-up. It addresses your local host here. On your real robot, you'll just open up your laptop, type in the robot's IP address, and you'll see this same screen. I want to look at what vision devices are available. I can keep this somewhat smaller if that helps. I want to see what vision devices are available. So I'm going to click on that. I'll get a new window. Well, hey, look it identified that there's an SC130EF available. I can go into live mode and see a live update, which right now wouldn't really show me much, but I can do a snap and take pictures. So while we're playing with that, if I go over here, if I were to take this camera and move it way down low, down here by this table, and then take a snap, watch this image update. So we're actually able to see perspective and location, all of that based on the virtual world. What's going on here in our setup is actually going to give us a really good idea of what's going on here. Furthermore, when I double click on this camera, or if I'd gone to my tree here and clicked on it, I can change the focal length, which is nothing more than what lens you have on the camera. So if I put on a larger lens, let's say a 25 millimeter lens, and I snap a picture, now I've zoomed in on that part even though the camera's up in the air. Let's take that same camera and put on an 8 millimeter lens. 8 millimeter lens, let's snap a picture. Now I can actually see, the part's way far away, I can see out the side of the table. So this is your first really nice tool as to sizing your lenses, your field of view, your work area, where the camera goes. Let's make a decision right now as we move forward as far as the height and the lens size. We'll make a decision and kind of stick with it and just see how it goes. We'll put on a 12. That's pretty standard. But what I want to do is I want to figure out what field of view I want to work with. So in this case, this robot can reach pretty much everything. So how I'm going to make my decision is going to be based on what calibration size I want to use. So in your fixtures, if I wanted to add a fixture from the FANUC library, there's a subsection called Vision Dot Patterns. There's a small, a medium, and a large. When you purchase a FANUC robot with a vision kit, we give you a bunch, actually more than just small, medium, large. I think you get 5 or 6 of these things, of different dot patterns. In my work cell, I have already added the large work cell. I did that before I started this video. So if I just make it visible, this is my dot pattern. Okay. I'm also going to briefly take my connecting rod and make it invisible. I don't want to deal with that right now. But what I do want to do is start setting up where everything's going to be. Okay. So I want my vision dot grid pattern to fill as much of the field of view of the camera as possible. And I want to pay close attention to these 3 big dots in the middle. These 3 big dots are going to help the robot understand what's the X direction, which is the 3 big, and what's the Y direction. That's the 2 big. So let's go ahead and line this up a little. We'll go here, we'll take a snap. That's not bad. That's a pretty good start. I can see that I'm losing a little bit on the bottom in that X direction, which would be the X minus direction. So I'm just going to go over here, go back into my work cell, take my dot pattern, which will be my working frame. I'm just going to scooch that forward a little bit. That's not bad. I've got all the dots in my field of view. So I'm pretty happy with this setup. That is very similar to how you'll do it in real life, in the physical realm, whatever it is you're working on. So at this point, we've done everything we need to on the virtual side to set up a camera, get it taking pictures. That's great. The entire second half of this video, starting now, is going to be on how you set up a vision process, letting this robot know where the part is, know where the camera is, marrying them all together. So let's jump into this a little bit. The first thing we need to do, I'm going to hide the part that this is carrying temporarily. Let's see, visible. I want you not visible, please. Perfect. The first thing I need to do is I need to set up a user frame. Okay, a user frame that correlates to this dot pattern. Now, RoboGuide, there is a quick way to do that and to cheat, but I'm not going to show you that until later because your real robot, you can't cheat. So, menu, setup, frames. Make sure that you're looking at your user frames. Detail. I'm going to name this let's just call it vision frame, something that you can remember. There are 3 ways to teach a user frame, guys. There's a 3-point method where you teach an origin, a X and a Y. There's a direct entry method, just telling the robot where your origin and everything is in relation to world 000. But for all vision processes, you've got to use 4-point. I'll say that again. Here's 3-point, here's direct entry. If you're using vision, you're using the 4-point teach method. Take that to the bank. That is because it adds something called a system origin. Let's set this up. As I look at this, I want, and your grid pattern will actually have this printed. It's not showing up here in RoboGuide, but on your real robot, this will have print on it that says 00, X, Y. You'll have everything printed on it, but I'm just going to have to tell you here, take my word for it. I want my origin to be here, my X direction this way, my Y direction this way. Think of the right-hand rule. And then the system origin is going to be that middle dot right here. In fact, FANUC even gives us a nice little white center point on that one that these ones don't have. So let's teach that. I'll show you how you're going to teach it with a real robot. You highlight your orient origin, and you would jog the robot down. I have a quicker way of doing it. Control, Shift, click. That's another benefit of RoboGuide. But I'm going to put my pointer right there, Shift, record. You can see the data went from being uninitialized to being recorded. That one's in the books. Done. Let's go up here. Control, Shift, click. There's my X direction. Shift, record. It's a heck of a lot faster than jogging, but that's because I have RoboGuide. Control, Shift, click. That's my Y direction. Shift, record. And then my system origin, which is right in the middle, right here. Control, Shift, click. System origin, record. You can see that as soon as I taught all 4, they now say I'm used, and they now have all their data put in there. It is saved. It's recorded. If I previous out, you can see the data in my user frame. So that's great. What you didn't see me do earlier when I was setting this up was setting up my tool frame. That's how the robot knew the TCP of the vacuum. That's easy stuff. But now this 4-point user frame is taught. It is pivotal that you do that first. Okay. Next steps. Let's go ahead and get the robot out of the way. I'm going to move him up. Get him out of the way of the camera. I need to take pictures, and I don't want to take a picture of the top of the robot. So we'll just get him out of there. Perfect. Let's minimize that. Okay, so we're going to open up Vision Setup. All right. I have some legacy stuff in here that I was doing earlier, so let's just delete my previous work. Delete. Okay, so here we are. We got a blank slate. Nothing's going on. It's going to walk you through. Push create to create new vision data. Sounds like a plan. Let's do it. So this is vision data. Okay, this first step is going to include setting up the camera, some of your exposure, and your calibration. So this is before we even teach parts or anything. This is just the data. So I'm going to call it connecting rod data, conrod data. I can even comment it and say calibration for connecting rod cam, something like that. That's all that is comments. This is a 2D camera, not a 3D, so 2D. I'll hit OK. So now I have a camera data process. Let's edit that. Okay, it's going to walk me right through. Anything that's red is not done and not happy. Once things turn green, they're done and they're happy. So right here, what camera? I want to use the SC130EF. As soon as I click it, it shows me what the camera sees. Perfect. Next, is this a robot-mounted camera? Anywhere you guys see this little bullet with an eye, you can always click on that, and you can get a nice little help menu. Okay, FANUC has built-in menus, and you can look and say, oh, a fixed camera is one that's up on a structure. A robot-mounted camera is one that's on a robot. Hopefully you didn't need a help menu to know the difference, but if you did, guess what? We have them. So in this case, no, it is not on the robot. Exposure time isn't going to do anything in RoboGuide. It's only going to help you in real life. RoboGuide has perfect lighting because it's in a perfect world. You will not. You will have LED lighting or something that's illuminating your surface, and based upon your aperture, how much that is open or closed, you can increase or decrease your exposure time to change the brightness to gain that contrast. Next, it's going to say, how do you want to calibrate your camera? We can do this automatically with a robot-generated grid calibration. For this video and for most of your projects, we're going to do it the easy way. We're going to use the grid pattern. Okay? Save our data, save our progress rather. So let's calibrate this bad boy. We are going to offset this robot. There's only one robot, so that can't change. Application frame. Think of this as, where are you doing your work? I'm doing it here. User frame 1. This is the one that we built. Remember, of all the frames, we built one called vision frame. That was that 4-point method right there. Now it's asking, what is your grid spacing? That's asking, what is the pitch between these dots? When you get your dots from FANUC, they will have printed along the side. It'll say, hey, these are the X millimeter pitch. If you're in RoboGuide and you're confused and you have no idea because it's not printed, simply use our measuring tool. Say from here to here. All right, I've got a measurement of 30 millimeters. Perfect. So let's jump back into here and answer the question. What is your grid spacing? 30 millimeters. So you can see all the predefined ones. We only send you all of these. 30 millimeters. Perfect. You do have the ability to calibrate these on multiple levels in case your parts are stacked and your part may appear bigger or smaller based on where it is in the stack. We're not doing that for this video. Don't worry about it. Is the robot holding the grid? In this case, no. The grid is sitting on a table. Okay, what grid frame do you want to use? We're going to stay consistent. We're using Vision Frame. We actually used the calibration grid frame to build the application frame. I physically laid this on the table and touched off on the points. Hopefully in your system, you have the ability to place and remove this grid pattern should you ever need to easily recalibrate your system. Again, projection. Perspective is going to have the camera consider the size of the part, meaning it's closer or further from the robot. Not quite 3D, but like 2.5D. For this case, don't care. Orthogonal. The part's going to be X, Y, or rotation. It's just going to be laying on a table somewhere. So, since I'm only doing a one-plane calibration and it's orthogonal, we have to talk about the first plane. Click Find. You'll be presented with this field of view of the camera and these nice little handles to drag around. You want to draw a box around encompassing all the dots, all right? Do not miss some dots. If you can avoid it, don't miss it. And also don't grab too many dots. If I grab over here, our vision camera might see that as a dot and you might get a bad calibration. So I want to put it just around this. Hit OK. All right, let's take a look at what the camera's seeing. As soon as I did that, it's intelligently marking the big dots for X and Y direction, and it's also labeling all these dots. This is your opportunity to look in real life and make sure there's not some green crosshairs over here because of an ink smudge that's ruining your calibration. This is a good quick check to make sure everything's okay. So now we just click the set icon and you'll see everything gets the happy green check mark. Everything's green and happy. We can click here and we can look at all the data of all our points and we can click through these. This is the screen where if you did have a bad dot, let's say dot number 29, if I click on that, you see him highlight over here. If dot 29 wasn't a dot, it was over here as an ink smudge, you can actually delete it. You can come over here and say, no, that's not a dot, get rid of it, and it'll make your calibration a heck of a lot better. And you can always look at your calibration results. You can see what your scaler is, how many millimeters equal a pixel based on your resolution. Obviously, I'm in a perfect world, so I have a super low mean error value, but that's what you want, ideally. You want a nice low error value. So you got some nice data here. We'll just click Save and get out of there. That's the black box magic. That's the beautiful part about FANUC and its integrated vision is all we did was drop a piece of paper under the camera, click Calibrate, and it's done. The robot and the camera now know where the frame is, how many millimeters per pixel. It's ready to rock and roll. So now we actually have to get to work. Let's get to work. Let's create a vision process. So I'm going to call this one Find the Rod. And you can give it some comment. But down here you can see all our vision process tools. Okay, and over here there will be a little description of what they all are. So obviously a two-dimensional single view, camera finding a part, multi-view, couple cameras or a couple locations to locate one big item that doesn't fit under a field of view. Are we depalletizing? No-cal, floating frame, all kinds of different things. Single view, which is just for pass-fail. It actually doesn't guide the robot. All this fun stuff. Today, we're talking about a two-dimensional, single-view process. So I'll hit OK. Here it is with my odd language comment. Let's edit this thing. Okay, so once again, everywhere that you see things in red means you've got work to do. You're not ready to party until this is all green. So again, you got the little help icons by everything. If you ever are confused, you can click on it. But let's just walk through this whole process intuitively. What camera? The Conrod camera shows up. What offset mode? We can do a lot of different things with offsets. We can offset by tool, which is telling the robot how wrong it's holding something. We can just get a position. Hey, where are you? The most common one, the one you're probably using, is fixed frame offset. That just means wherever the part is in that application frame, we're going to offset the robot's motion and go get it. So that's the popular guy. What user frame do you think we're going to use? Hint, it's the one we built. As we keep going down, there's some things we're going to skip over. Sortation for sorting key and sorting order. If I had a bunch of connecting rods on here, I can tell the vision, what to do with duplicates, or do I pick them left to right, top to bottom? Do I pick them by best score, worst score? Do I pick them by angle or size? I'm only picking one part for this video, so I'm not worried about it at all. What do I want to do with image logging? Do I want to log all my images, failed images? Right now I do not care. Not going to log anything. Right here, when we get to this reference data line, I'm going to stop. I'm going to stop you right there, and we're gonna go somewhere else before we get to here. Reference data is the magic button that marries robot motion with camera vision. What does the camera see and where's the robot going? That's where we build that reference. So that'll be our last piece. So as we go through here, again, some of these tools, listen, FANUC has an awesome training course to teach you everything you need to know about vision. I'm not going to be able to knock it all out in a half-hour video, but there's a lot of parent tools, child tools, things like that you can learn. Bear with me on this one. We're doing a simplified version. But a snap tool is where you can deal with your image resolution, your exposure time. What do you have for LEDs, triggers? I'm not dealing with that. I want to go here. A GPM is a geometric pattern matching tool. This is a tool that is going to find my part based on shape. Well, right now I'm looking at a calibration grid, which does me no good. So let's go back to our virtual world here. Let's take my grid, make him go bye-bye. And let's get that connecting rod back in here. All right, cool, I've got a connecting rod now. If I go in here and I do snap, there's that connecting rod. It's perfectly in the field of view. Life is good. I need to teach that, so I'm going to click teach. When I do that, I get this nice little box. All I have to do is draw a box around the part. And FANUC is going to intelligently do the rest. Click OK. You can see on the screen here everything highlighted in green. Everything highlighted in green is a high contrast edge that iRVision found that it considers part of the part. There are a lot of tools for training masks, emphasis areas, all of this fun stuff that I can use to highlight, delete, accentuate these parts. Not getting into that here because this is a perfect tool. It's taught perfectly. I'm going to leave it alone. But know there are tools to make it better. There is a section here for your score thresholds, your contrast thresholds, straightness of lines. We're going to skip through a lot of this right now, but these are tools to help you define what's a good part, what's a bad part. Scrolling down, I can modify my search windows. I can tell the robot to ignore parts unless they're within a certain orientation. If this rod was 90 degrees out and I say, no, I don't want to go 90 degrees, I could always put in a 90 right there. For this intent and purpose, I want everything. All fun parts of dialing in your vision process that don't really matter for right now, but I'm going to save this. Down here, I want to use snap and find. Okay, that's telling the camera, acquire a new picture and go find me a part. Well, it did. It took a picture and it drew a box around the part that it found. Perfect. So now we know that this is working. Let's go back to our parent process. We left off at this magic reference data part that you might recall. And now it's time to actually use that. So here's what we're going to do. We're going to click Snap and Find again. Make sure it snaps and finds. Okay. We see some nice little data down here. It says, hey, I found your part. The center of mass of your part is about 26 millimeters positive X and 16 millimeters positive Y from the system origin that we built. Remember those 3 dots that were right around here? It found the part. What we need to do is, now that the vision system knows what a part looks like and knows where it is, we need to go into our system, into our actual physical system, and have the robot come down to where this part is. Again, I have the luxury in RoboGuide of cheating. I can say move to, and the robot's gonna put it right there. But in real life, you guys need to drive the robot to the position where you want the robot to pick up a part. Do you want it to pick up on the end, in the middle, wherever? You know, I'm choosing the center of mass. You have to pick up the part. So the robot's in position. The camera knows where it is. All we have to do is click set. Here we go. So I've clicked the set icon. Everything went green and happy. That's it. We've married the data of physical robot position to position on the screen. We can save our work. We can get out of there and close that. Don't need this. We have now, in over the course of 30 minutes here, we have set up a camera, calibrated it, and taught our position. That's great, but guess what? Now we got to program something. I'm not going to leave you hanging. We're going to do the fun part. This is the best part of any project is programming things. So here we go. This robot's going to need a home position. It's going to have a reference pick position. And if you know me, you know that I like to put in offsets for approach and retreat for picking up a part. Well, the robot is currently still where we left it in that ref position. So now would be a good time to verify that I have user tool 1 on and user frame 1 on. I do. And now would be a good time to teach a position register. We want it to be a PR of our ref pick position. Shift record. Done. So now I have this location saved in the robot's memory bank. For my approach and retreat positions, 0, 0, 25, 0, 0, 0. Very good. And we also need a home position for this robot. Something that's out of the way of the camera. So let's just give them a little, let's do something like this. Looks like a great place for home. Shift record. Very good. Let's build a program. Create. I'll call it main. And I like to do split screen. It always helps to see some data over here while you're working. I'm always a fan of putting in a bunch of lines of code and then just filling it in. Best lines of code anyone can ever write are these first 4. If you've seen my other videos, you know that's true. Define what user frame we're working in. Define what user tool we're working in. Define what payload the robot is using, and define what speed that you'd like to run. That's 4 lines of code you can write. So next, let's put some motion to this bad boy. I would like him to start at my home position at PR1. I'm going to skip a few lines of code. Some magic's going to go in there in a minute. But let's keep building the easy stuff. I want to move linearly to my reference pick. A little faster than that. And I want to have a approach position. So this line of code, as you can see, this line of code, as you can see, will put me 25 millimeters Z above my pick position. So that's good. I like to copy and paste. A little speedier to do it that way. Make this be a fine move. Cool. So now you can see that I am above the part, then I'm at the part, then I'm above the part again. Seems like a good thing to do. We also need to pick up the part. We'll add that. Copy that. Paste. Cool. So we're going to start at home, go above the part, go to the part, go above the part, go home. Looks like a pretty easy program. Right here's where I actually need to pick it up. If this is real life, you're probably turning on a robot output or digital output. But for me, I need a simulation program. Pick up rod. I would like to pick up the connecting rod from the table with my gripper. Let's go back into our main program. And we will call that pickup rod. So here's a really nice program, guys. This is where we were in my previous RoboGuide tutorial. Start here, go above the part, pick it up, get back out of there. Life is good. Oh, except if I was a really good programmer, I'd have this in the right spot. Just goes to show you, it doesn't really matter how long you've done this. You can always make mistakes. This is why you debug code. So above the part, down to the part, pick it up, little dwell time to make sure whatever your vacuum turns on, and then back above it. Sequencing, guys. All right. So now, where does vision play a role in this pick and place program? Okay, where does vision turn into anything? I'm going to make this screen a little easier to read for you guys now that we're here. I'm going to go Instructions. Down here, there's a new menu called Vision. See a lot of fun stuff in here. We're not going to talk about everything in this video, but we are going to talk about the first two, which are the important two. Let's click Run Find. So at this point, you know that the robot is at the home position. It got there and it stopped. The next thing we're doing is we're calling the vision camera to run a find of what? Find the rod. If we had more vision processes for more parts, you'd see more, but I only built one. Find the rod. So now with the robot out of the way, we tell the camera to find the rod. Perfect. Well, now that you found the rod, now what? I want to know where it is. I want to get the offset. So, vision, give me the offset of find the rod. What do you do with it? I want you to put it into VR1. What's VR1, guys? Vision register. We've already used PRs for position register. This is going to VR, vision register. Next, this jump label is a predefined function that says if I try to find a part and I can't find it, that means I have no data to put in VR1. Where do I go? I want you to go to label 99. What's label 99? something we're going to put down here, label 99, that basically we failed. We didn't find a part. There were none left. It was out of the field of view. It didn't match the GPM. So we just want to jump down here and skip all of the code in the middle. So now that we have the run find data, and this has put some numbers into VR1, guess what? Now we have to use VR1. All right. So take a look at this line. Right now we're moving linearly to the reference pick position. If I go to the end of this, which is actually another line here, but if I go to the end of this line and I look at my choices, you can see down here that I can do a vision offset of a VR and amend that line. If I go like that, I am moving linearly to this position, but I'm adding whatever offset. And you remember when we took a picture of the snap and find, we were already getting that offset. It said that we were 26 millimeters north and 16 millimeters west and 180 degrees of our center. This vision offset is going to apply vision data to that magic golden position. I also want it here, because as I approach the part, yes, I want to be 25 millimeters above it, but I want to be 25 millimeters above where it actually is. And of course, when I retreat, same story. I want to retreat above where the part was. Split this screen so you can see the total program in its entirety here. I think I can fit it all on one page. Start from home, take a picture, get the data, then move with your offset, pick it up, move with your offset, go home. At this point, we just got to play. We just got to test it and see that it all works. So I'm gonna get our robot in the field of view here on the screen. Scooch this over here. Start at the beginning there. Make sure my speed's ready to go. All right. So right now the part is right there. It's in the golden position. We'll test it there first, and then we'll play a little bit more. There we go. Robot went and got the part. So we know, if nothing else, we know that our program works. We know that the robot can go and get that part. Well, now let's have some fun. Hide that. Let's change where this rod is. Okay, maybe this rod isn't right there. It's over here. Maybe it's up here. Maybe it's crooked. As long as that rod is still in the field of view of the camera, we should be able to go get it. Let's see. And we got it. So that same program was dynamically able to say, all right, I see it, I found it. If we want to go see where that is, we can go to our Internet Explorer. We can look at our vision devices. You can see where that rod is on the screen. You can see that it's way over there. Let's go ahead and trip it up even more. Let's open this. Let's flip this thing completely upside down. Let it be upside down. And let's move it over here. Apply. Let me take a look, do a real quick snap, make sure I still have it somewhere in the field of view. All right, it looks like it's still in the field of view. Robot should be able to find that. Let's see how well it does. Here we go. Found it, picked it up, and then you see that it went right back to that home position, rotated it right back around. So even though it was completely upside down, the robot was able to twist down, pick it up, and get right back to where it needs to be. Let's run that again. You see that it straightens itself out. Perfect. So there you have it, my friends. Some pretty straightforward stuff there. We covered a lot in a very short amount of time. For more details on this, please consult the FANUC training. We've got a training course that goes over this, spends a few days with you. We have them online or in person that'll really teach you all the ins and outs, all the tips and tricks. But now you know that in RoboGuide, you can get this thing running just about perfect using the vision, using the sensors, setting it up on your teach pendant, and then you can upload that to your real robot and save a lot of time. Any comments, questions, please feel free to put them in the comments. You can always contact us at 888-FANUC-US. And everybody, have fun coding.